So the shape of the sampling distribution for sample means, well, if I have a small number of samples, it could be any shape. It could be skewed, bimodal, asymmetric, but if the samples are large enough, and we have a rule of thumb for large enough, and that is 30, then it will look like a normal distribution. Now, in real life, the size of the, or the, rather the shape, so the shape of the population really sort of dictates. So we're going to put in real life down here. The shape of my population will determine how big my sample needs to be, but for our rule of thumb, we're going to say in order for it to be normally distributed, n has to be greater than or equal to 30. And then when all the conditions have been met, SRS, normality, remember with p hats, we were also looking at, is it normal? So same thing is true for sample means. So if I have an SRS, remember I can't screw up my data collection. The normality and the population is at least still 10 times larger than the sample size. Then I'll be able to use my formula without any worries. And by that I mean my standard deviation. So now this whole normality piece, I actually want to talk a little bit separately about that. I have a couple of ways I can test normality for sample means. So actually I'm going to erase that. So one way I'll know if my sample means are normal is if it states that it came from a normal population. So if the population is normal, my sample means will be normal. And if I have a sample size that's large enough, so this n greater than or equal to 30 will also assure me that my sample means are normal. If I don't have either of those, I'm going to have to graph my data and make a decision about normality as best I can. And we'll see some of these examples, so you'll have an opportunity to look at what happens when it doesn't give me the population is normal or the sample size is big enough. So make sure you've stopped, paused long enough to actually read this prompt. Remember, I spy with my little eye some information. So first thing I see is normal distribution. So of course I would underline that. And that was for all the population, all the adults. And then they tell me the mean for the population and the standard deviation for the population. And then I move to part A and I notice, oh, they gave me sample size, back to simple random sample. So all of that stuff is important. And so I want to figure out what's the mean. So I want to know mu of x bar. And I want to know standard deviation, again, of the sampling distribution x bar. And so sigma of x bar. But we remember that mu of x bar is just equal to mu. So that's going to be 25. And the standard deviation is equal to the population standard deviation over the square root of n. So we'll have 7 over the square root of 10. And that works out to be about 2.21. And don't forget, if the population is greater than or equal to 10n.